Hello MYP5. Okay, today we are going to look at transformation of exponential functions, right? All right, my original transformation graph will normally have this equation: y is equals to b to the power of x. I can always write a small b or a capital B, right? So y is equals to b to the power of x, and we are going to be translating using that. So a value is multiplied to it, and then a number is added or subtracted in the power, and a number is added on the side, right? You did transformation when you did quadratic graphs the other time, and then we are going to be working more on that. Okay, let's see how these different alphabets, what do they do to the graph, how do they transform the graph. Okay, if a is a negative value, the graph will be reflected on the x-axis. If a is a positive value greater than 1, more than 1, it's a vertical stretch. If a is a fraction value or a decimal value which is supposed to be between 0 and 1, it is a vertical compression. Right? Next, let's look at the value for the b. Value for the b here. For the b. So if b is a value greater than 1, it's an exponential growth. If b is a value between 0 and 1, it's a decay, exponential decay. Right? For the h, can you see I'm operating it with the x? Right? So if h is a horizontal transformation, that means you'll shift your graph sideways. Right? If h is positive, you move left. If h is negative, you move right. Like the way when we were looking at the quadratic graphs, shift on the x-axis is always opposite in meaning. When it's a positive 3, you move towards the left. When it was a negative 3, you move to the right. So same will apply here. If it is a positive h, you will move left. If it is a negative, you move right. That's opposite in meaning. But it's not the same when you're moving up or down, right? Up or down, we're going to be doing the movement the way it is written. If it is a plus k, then we'll move up. If it is a minus k, then we'll move the entire graph down, whatever units. Right? Okay, we are going to look at a few examples together. Right, let us look at our first example here. It says y is equals to 4 times 3x to the power of x minus 2. 4 times 3 to the power of x minus 2 plus 6. So we can see it's a vertical stretch of 4. It's a positive whole number, right? More than 1, vertical stretch of 4. Then since this is a positive whole number greater than 1, it's an exponential functions, right? That means it's a growth function, right? Okay, this minus 2 will mean I will shift my graph 2 units to the right. There you go, 2 units to the right. And this plus 6 means we will shift the entire graph 6 units up. Okay, another example number 2. So y is equals to 1/3 times 2 to the power of x minus 4 and a minus 5. So I can see it's a fraction, a value between 0 and 1. So it's a compression by 1/3, vertical compression by 1/3. And this value is 2. So growth function, it's a growth function, right? Minus 4, that means I'm moving right 4 units. This 5 means I'm moving down 5 units. Thank you.